All right, so warm up number 1. We'll do number 2 in a minute. So what does that look like? Definition of a derivative. So this is the derivative of, because it fits the format. What's it the derivative of, though? So it's the definition of derivative. What's in the role of f of x? Cosine. So this is the derivative of f of x. And what's the derivative of f of x? Lucas, what's the derivative of, or excuse me, what's the derivative of cosine?
Derivative of cosine is negative sign?
Yes, it is. So that means that whole mess is the derivative, because it fits the format of a derivative, of whatever's in this spot. So the derivative of f of x, the derivative of cosine, which is negative sine. So f of x, this whole thing is negative sine of x, because it's the derivative of the cosine. What does instantaneous rate of change mean? Let's see. Rate of change is like a slope, but instant slope, as opposed to average slope, is this algebra or calculus? It's calculus. Oh, average rate of change is just algebra 1 slope formula. Instantaneous rate of change is calculus. That's f prime, the derivative of f. And we want it at pi over 4. So first job is to find f prime. So if f is negative sine, then f prime of x is what? Yes, but is it, so if f is negative sine, its derivative in is, because derivative of sine is cosine, so derivative of negative sine would be negative cosine. So the sine goes with it. So again, this one's negative, not because the derivative of sine is negative, but because that negative is that negative. The derivative of sine is cosine, but that negative is still there. So at pi over 4, that would be negative cosine of pi over 4. Cosine of pi over 4. Draw the picture. They're both root 2 over 2. So negative root 2 over 2. So that problem is a good one you will see again. Forced you to take two derivatives, forced you to know what the definition of a derivative looked like, and you had to do a little bit of trig right there at the end. So you'll see one pretty similar to that on the test. All right, number 2. Why don't you try number 2? It's a chain rule to find the derivative, but then use that to do a tangent line. All right, so chain rule, and this has more pieces to the chain than what we usually have. Usually there's 2 things. This has 3 things, and for some people it's helpful to kind of identify the things even before they get started. So like outside in, this one's a little confusing because the squared is the outermost thing, even though it's not like written on the outermost thing. So that's thing 1, if you want to think Dr. Seuss, thing 1 and thing 2, and thing 3. There's thing 1. Thing 2 would be the cosine. And thing 3 would be the 6x. So we got to chain all of those pieces together. The 3 out front, that's just a coefficient that's just kind of going along for the ride. So I've got something squared. That's the first thing I need to handle. Well, anytime I have something squared, the 2 comes down front. Everything else gets raised to the first. Or whatever was squared is now to the first. So what was squared was, whatever was squared is now to the first, so cosine of 6x. So the 2 and the first is sort of that was the first chain, the outermost layer. The second layer is now, what's the derivative of cosine? Well, that's negative sine. Be careful so that it doesn't end up looking like subtracting sine. It's multiplied by negative sine. So negative sine of 6x. So that was thing 2. And then thing 3, the derivative of 6x would just be 6. And so the chain thing is cosine changed to sine, not changed, but chains, and then 6x chains to 6. So again, you can think of it as chaining them together, or you can think of them as the Tootsie Roll Pops, where you outer layer to inner layer. And this one is different than most of the ones we did because it had 3 layers to worry about rather than just 2 layers. So that's fine as an answer, but we should probably clean that up a little bit. 6 times 6 is 36. Probably move the negative out front. We don't really need to write cosine of 6x to the first. We can just write cosine of 6x, sine of 6x. All right, so now use that to find the slope. And there's your point, so you should be able to write a tangent line. So I'll give you a few minutes to do that. All right, so to find the slope, because tangent line means slope and a point. Slope and point. We have the point. I could have made this one step more difficult by just giving you the x value, and then you would have had to plug in to find the y value. Right, f of pi over 18 would give you 3/4. But we're good with that. I gave you the point. And sometimes the book gives you the point. Sometimes it just gives you the x value. It's just, sometimes you got to have one extra step in there. But the slope is derivative. Slope is derivative. Slope is derivative. So f prime at pi over 18. So we want the slope, or the derivative, the instantaneous rate of change, at pi over 18. Negative 36, cosine of pi over 3, because 6 over 18 becomes 1 over 3. Sine of pi over 3. So I have the values memorized, but usually I need to draw the picture to make sure that I know what I'm doing here. So pi over 3, that's the steep angle. Let's see, that means the short side is 1/2 and the long side is root 3 over 2. It's always cosine comma sine. This one's kind of nice because since you need both of them anyway, if you get them backwards, I would never know unless I was really paying attention. But the cosine of pi over 3, that would be 1/2, and the sine of pi over 3 is root 3 over 2. So let's see, 36 over 4 is 9. So negative 9 root 3 is our slope, is our derivative, is our instantaneous rate of change, is our dy dx, is our f prime. I don't think there's any other ways I can say that, but all those mean the same thing. Derivative, slope, f prime, dy dx, instantaneous rate of change. So y minus y1, so using that point from up there, so y minus 3/4 equals the slope times x minus x1. That's an ugly tangent line, but we don't have to clean it up, so we're fine there. Again, test inspired, though that one not as directly as the previous one. For this particular one, I combined several questions to cover as much as we could in one warm-up, right? There's tangent line in there, there's derivative of sines and cosines in there, there's trig in there, there was a chain rule in there, slope and point, so there was a lot covered in number 2. So I don't know that any one on the test is that bad, but definitely all the pieces of number 2 are on the test. So I made a warm-up that was worse than the test, but covers, like 3 or 4 test questions.